Yeah, as I said, this is most of the textbooks. They will not uh, include this law in the gas law. But my I'm leaning towards I have to put it in both ways because it is a gas and it is a gas solubility in a solution. So this gas law calls Henry's law. Henry's gas law. So Henry's gas law is not put in your chapter in your ebook or any textbook. They put it in the solution uh, chapter. Chapter talks about solution or discuss solution. Then they put Henry's gas law there. But I prefer to even to put it both ways because it is a gas, and the concentration. That's what it says. The concentration of a gas dissolved in the solution is direct proportional to its vapor pressure. It's a vapor pressure. So what it says is, and that's really Henry's law. As I said, you'll not find it there in the gas laws in any textbook. They put it in the solution, but I really leaning towards we have to have it. This is law number 8, correct? Law number 8, I think. So what's happening is the vapor pressure of a gas. Oh, thank you very much. Dankeschön. The gas pressure is direct proportional to its concentration. C is molarity or called concentration. So then we can take this relationship and say, okay, peak of the gas is equal K C. K called Henry's constant. Henry's constant. So it means this is the law here. Concentration of the gas. The gas is dissolved inside the solution. And if the pressure is very high, the concentration is very high. If the pressure is less, the concentration will be less. So now I'll give you an example. If you have a soda, correct? Inside soda, beside too many acids. Can you count how many acids? We did that in one of the lab experiment long time ago. How many acids in soda? They will not tell you how many. Therefore, soda is not healthy. Gatorade is much more healthier. By far is the best. Any Gatorade because it has ions, electrolytes, which is really rehydrating the body. If you are dehydrated and you want to rehydrate your body, you have to drink not sodas. Sodas is really nothing than just a magic taste food, organics plus acids and full of your hand of sugar, 24 grams or 25 grams of sugar. So mostly sugar and what? Acids. What are those acids inside? We did this one here, by the way. We did determine even we titrated one of the acids there. Anyway, how many acids inside? They will not tell you. How many acids there? So there are, a major one is carbon dioxide dissolved in H2O. That's carbonic acid, correct? Then you have ascorbic acid. You have citric acid, phosphoric acid, four acids. Now, if you drink those acids with the soda, your stomach has what? Hydrochloric acid. So you drink a soda plus four acids plus acid in the stomach. So if you drink too much soda, you get what? Heartburn. Correct? The problem is not with the heartburn. What's the problem with the sodas? Too much of soda. Somebody will tell me. I don't want to make you a chemist. What's the problem with the soda? You have acids, and those acids will dissolve in the long run the gum tissues underneath the teeth. And you'll see a guy is like 20, 21, or 19, or 18. Most of the teeth are out. Yeah. Looks like you're a 100-year-old person. Why? Because that person is addicted to sodas. Like I don't know how many per day it's taking acids. That's affecting what it dissolves the gum tissues underneath. But it's not one day. It's a couple of years. It takes a couple of years, and then when it hits, the whole tissues are dissolved by time. The whole teeth you are losing all your teeth. Therefore, it's not healthy. Uh, I did not realize that until we took experiment. Then over 20 something, 25 years, I have never taken any sodas. Although my wife and kids, they are fighting me like death. They love the fuzzing, this carbon dioxide coming. Okay, so carbon dioxide, the fuzzing is the concentration here of the soda. When you open this soda, it's carbon dioxide gas escapes, correct? Escapes the soda can, and therefore here the pressure will decrease. So the concentration will decrease, and the soda is tasting, they call it flat. Flat taste of a soda means you have lost carbon dioxide, the fuzzing gas, correct, out of the soda, and therefore, because as soon as you open, the pressure is higher than atmospheric pressure inside the can. As soon as you open, then it will equalize itself with the atmospheric pressure, which is less what was to begin with. So carbon dioxide will escape, and there is no fuzzing, there is no, and the soda is taste flat. They call it flat. You heard about the word flat soda? Yeah, that's what you have lost a lot of carbon dioxide inside. So how many now? I'm repeating myself. How many acid? Carbonic acid. That's the fuzzing gas. That's the flat causing, when it escapes, causing this flat taste. Carbonic acid, phosphoric acid, ascorbic acid, citric acid. 4. The stomach is hydrochloric acid. So it's not only the heartburn, the problem is this dissolving your gum tissues per time, not 1 year, maybe 10 years. I have one, Professor Mark in the history was telling me, one of his relatives is a young guy, is about in his 20s, and he lost all his teeth. The history, Dr. Mark, Professor Mark is my friend. Not Mark Graves, that's a biologist, that's a history teacher, is a friend of mine. We are here for a long time. Yeah, almost, yeah. So, and we were talking about this, and I explained to him. He said, now I understand why this, my relative had lost his, and he's young, very young. I said, did you ask him? I said, yes. He's taking like 5, 6 soda a day. That's too much. 5, 6 soda a day. So came a couple of years, 5, 6 years, he lost all his teeth. At that time, I think now he has maybe implant or something. But even if you have new implants of teeth and you still take soda, the implant will not help. They will be dissolved as well with those acids. So they don't tell you that there are too many acids inside. But anyway, so you can try it yourself, but I would be moderate. I could not prevent my kids, which are not, nowadays they are not no more my kids. They're in their 40s, so they're acting like they know everything than their dad. So if you have a kid in the 40s, so they act friends, you know. So they are my friends now, not kids. Anyway, can I take this one out? Let's take worksheets. Can I take this one? Everybody has it? Okay, let's take some worksheets here. So this is in the iCollege. So I did not bring anything from outside. This is just long time, but those are very good ones. They are still valid. I mean, but you might find even better and better one than this than those here. But those are the major one you'll find. Then we'll find even new ones. So first we'll get to the Boyle's law. We'll take just one question from each. So we'll take about eight ones. This is the abbreviation, what you need. I give you all these examples. So choose one of those. You have 7 of those. I need as a, like number 4, number 3, number 2, that's what they come. Number 6, they don't bring you some. This is a conversion. This is a conversion. They will not tell you direct convert is not coming as convert. It will come as problems. So it comes as a problem. So which one you like? I can take in a snipping tool of it. So which one you like? One, only one. That's Boyle's law. Which one? 2. Okay, that's good. I like it. I like it. So let's take 2. Okay, 2. So, and we will have this, as I said, the easiest one ever, but the easiest one is the nuclear chemistry chapter. This one's easy too, but the problem is that you have to very tricky with the units. So let's see here. Next one here, and home, and then I'm pasting this. So a gas, always in those type of problems, you write what is given, what is asked. So here it is. You make a table yourself, or just here is given, and here is asked. Small tiny table or whatever. So like this. Given is a gas temperature. So T1 or T initial, correct, is 25 degrees Celsius. And this has a volume, V initial, has what? 3.60 liter. And the pressure is 1.00 atm. That's given. What will be the volume? The volume final at asked here, at this is initial here, at P final is, how much is it? 2.50 atm. So now if you look at this, there is what's really changing is the relationship between, if you look at this, the temperature has nothing to say here, just to let us know it's at this type of setup is at constant temperature of 25. So this one here has nothing to say, so just leave it alone. Okay, the real relationship is this one is changing, this one is changing, this one is changing, this one is changing. So the relationship is between the volume and the pressure. This is Boyle's law, correct? Boyle's law. And Boyle's law, if you look at this, PV1 equal PV2. This initial, and this is final. Set it up, correct? So now we don't have any to worry about any units, because the pressure here, the initial one is 1.00 atm. The pressure has to be given in atm, multiplied by the volume. Initial volume's 3.60 liter. That's liter, correct? Equal to 2.50 atm. ATM, correct? So we don't have to worry about any units here. And V2 we don't know. So how we solve this problem? You know that. So that's eight or nine grade math, correct? So you have this one here, and you wanna solve for V2. Somebody will tell me how we do it. That's 8, 9, not 8. I think 8. Is it 8? Somebody will tell me. That's a long time. My kids is grown up now. I don't remember what. But that's I have to solve for this. Correct, V2. So what should I do? The easiest way is divide both sides by what? 2.50 ATM, correct? And 2.52 ATM, correct, guys? So 2.5, I'm isolating the other side, V2 by itself here, equal to 1.00 multiply ATM cancels the ATM, multiplied by 3.60 liter divided by 2.50. The ATM cancels out. Now, what I have to watch for it is the sig fix. This is 3. This is 3. All of those 3. 3. Sig fix. This is 3. Sig fix. So my answer has to be what? In liters, 3 sig fix. So from what I can say, it's 1 point something, correct? 3.6 divided by 2.5 is 1 point something. So somebody has it? 1 point, see it here, 1.44 liter, 3 sig fix, yeah. So those are very straightforward problems. Now, time of this, sometimes there will be a very tricky questions on those types. So what they will do here, just to show you, oops, sorry, let me just, I did not ask. Everybody has this? Everybody has this? Okay, so then I'll take it out. So let's take it out here. Now this is straightforward, there's no problem with this. We have no issue with this. However, if I look at the sum of the problems, what is happening here, they will give you something. Nobody said number 5. See, nobody told me number 5. That's the trickiest one. See here, nobody said number 5. You took the easy one, the cheaper one. You did not take the expensive one, number 5. I did not say difficult one, but it's cheaper one. So why? Look at this. Here is the units is different, correct? So let's do 5. That's a very important one, because the whole chapter is about unit conversions, and we have to understand this gases, because you use gas law, then we are using specific unit for each of the conditions we are using. So take this one out, and oops, let's take this one out here. Okay, guys, so I can do it the same way we did, ask and then, but so we are now professional, we don't need a table, just put in the top of it, this is my V initial, correct? This is my P initial, okay? This is my V final, okay? And what is the standard pressure? This is P final. Standard pressure is what? Somebody will tell me. Standard condition is 1 atmospheric pressure and 0 degrees Celsius, or 273.15 Kelvin, or 32 Fahrenheit. 32 Fahrenheit, then you have 0 degrees Celsius, but we use Kelvin because we have to use Kelvin. Standard pressure is 1 ATM. I'll put this one here because this 444, I can put this one here 1000 ATM. So it'll make everything four sig figs. Okay, guys? So then Boyle's law, because it's dealing with pressure and volume, that's Boyle's law. Boyle's law will be P initial, V initial, PV final. So let's look at this. We have a problem here. We have 500 milliliter. We cannot use this unit. What's the unit of the gas we have to use in this chapter? Liters. So I have to divide this one here by what? 1000 to get liters, correct? So I will say, and the pressure here, millimeter mercury, I have to put ATM. So this one here to be converted to ATM, and this one here converted to liter. So let's start. So the pressure, the initial pressure is 7450 millimeter mercury. So guys, here it is, millimeter millimeter mercury over 1. I can do it brackets or just table. So I have 1.000 ATM equals 760.0 millimeter mercury. So millimeter mercury with millimeter mercury cancels out. So it will be 745 divided by 760, and the unit is ATM, 4 sig figs. Both of all those I've kept them 4 sig figs. Now this is P initial. Okay, guys, and the V initial here in milliliters. So we have to get rid of this milliliters. I have 500 0 mils. I have 1.0000 liter here. Liter here equal to thousands milliliter. It will not take this. Milliliter cancels out. So it's not allowing me to. But anyway, so therefore, and the other one is ATM. That's the standard one, 1 ATM. Okay. Let me take this and put it back in as a formula. Fine. Okay. Can I take this one? Everybody has it. Everybody has it. Okay. Let's take it again and then say the initial one we have here. Green 500.0, isn't that this one here, correct? Over what we said, 1000, and milliliter cancels out. This is 1.000. I want to keep it, the 1000 is whole number, but this is because it has a 4 sig figs. I want to keep it as this one here. This is liter. This is the V initial multiplied by 7.450, and this is 1.000. How many we have? 3, 4, yeah. ATM 760. So equal to, and I have here, what will be the volume? Well, the volume we don't know. That's V final multiplied by 1.000 ATM. So out of this one here, you can see the ATM from both sides, left and right, can be cancelled. So ATM with ATM cancels out. So the only unit you have, this here, this is your V initial, and this is P initial. Somebody has the answer? Get this value here, which is really is 0.5000 liter, multiplied by 7.545 divided by 760. How much is it? Let me just do it here for you. Okay, guys, 7.745 divided by 760. So point what? You have to get it the same thing here. 0.989802 for fix. Correct. Thank you. 0.002 ATM. This is the left side of the equation. Equal what? Equal V multiplied by V final. Because the one is already gone, correct? The one is already gone with atmosphere cancels out. So this is, if I take this one here, multiply it by this, then I get the answer. So let's take the answer here. Out 0.9802 multiplied by 0.5. The answer is this one here. Oops. Here it is. V final equal to 0.4901, and this is in liters, or thing in liters. So that's you have to watch for the unit cancellation and unit conversion. Okay, so let's take another one. Okay, guys, take this one out here. Okay, guys, can I take this one out? Everybody has it? Okay, let's take it out. Okay, let's take this one out too. So, guys, let's take the second one, the second law. Not this one here, this one out. Let's take the second law, which is, what's the second law? Somebody remember? Charge, correct? Charge law, I don't know. We'll take one of those seeds. The main thing, we don't need an answer. Yes. Let's choose one. That's Charles law here. This is Charles law here, guys. And if you look at Charles law here, this is Charles law, correct? And this always initial, and this always final. Initial condition, final condition. Now, I would like to take the one that have what? The one has different units. You see, one in Kelvin, one in ml, one centigrade Celsius, one. How about this one here, guys? This is a good one because it has. Let's do it here. So, neon gas was heated from 50 degrees to 150 degrees. Its new volume is 175 ml. What was the original one? The original means what? The initial one. Okay, the initial one. So, can I just put this one in as is? Yes, I can. So, but we can take this one here and make. Everybody knows how to use the snipping tool, correct? Don't let me down with this. Everybody knows by now. Especially you are in my lab, you have to use it because you have to snip some of the post-lab questions or so. Yeah, that's free. You don't have, as I said, long time ago, that's very expensive, close to $50. Yes. Yep. We department chair. I bought it from faculty. Remember, if you have 20 faculty and $50 CC, that's $1,000. But anyway, so can you see this one here? Let's put our whiteboard here. Take this one out, and let's put this one. Here it is. So Charles' law is, everybody remembers, V1, T1. 1 means initial. We know by now, correct? V2, T2. Now I'll make it quicker. So now you are very professional. You know that V is 175. Well, I take here ml, just 1,000 ml per liter, correct? That is V1. So ml with ml cancels out. So the units here, ml cancels out per 1 liter, correct? Per liter. So this is V1. Now T1, the initial one, is 50 degrees from 2. 2 means to the end, the last one. So 50 degrees, can I use it as is? Can I use it as is? What should I do? What should I do? I have to convert it to what? To what? I'm not here. Kelvin, yeah, don't be shy. I can understand. Today is what? Monday. Thank you. Thank you very much. So in order to have this one here, I will say, well, 50 degrees, I have 100 from the scale long time ago, remember? But then after that, you will just add 273. 100 Kelvin to 100 centigrade Celsius, correct? 100 to 100 cancels out. Now we have it, centigrade cancels out. I have 50 Kelvin, then I have to add to it 273.15 Kelvin. So this is the temperature here, T1, correct? Now, this is T1 here. This is the initial one. We converted this one here. So this one will equal to, now I'll make it shorter then. Or let me take this one here, the low here. Can I take this one here? I'll take this one here so I can use the space of it. So I'll put it in the top. So it is. Okay, guys. So we'll put Charles' law in the top here. V1, T1 equal V2, T2. That's Charles. Okay, Charles gas law. So, okay, guys. So now this is V1. So how about, that's always V1, and this is T1. I will do the same thing. What is the original volume? V2. That's I don't know. That's a question mark I have to solve for. T2 is 150, so I'll do the same thing. Now I'm professional. I know I don't have to do this conversion. I know this is. So 150 degrees plus 273.5, and this is in Kelvin. So I reduce the whole thing. Going from centigrade to Kelvin, I have to add 273.15. If I go reverse, then I have to subtract. Okay, guys, so now Kelvin, let's take the units out here. Let's see here. Kelvin with Kelvin out, correct? So, and remember, this is just 50 plus 273.15. Now somebody will do it the same way. What you will do? Cross and multiply, correct? then you can solve for V2. So how much V2? Somebody has it? 100. This is one. Sorry about this here. This is one here. So this is 1,000. So this one here, 175. This is just equal what? This one equal what, guys? 0.175 liter. 0.175 liters. So first you add 150 plus 273.15. That's the addition. Then whatever the value, multiplied by 0.175 divided by 50 plus 273.15. First multiply. You know how to do it, guys, or you need my help? You know how to do it, correct? Just add those up. The value of this multiplied by this value. And then the answer of this divided by this value. And the answer has to have, since here we don't have any decimal, and that's the problematic stuff here. We don't have any decimal at all. So our answer will have no decimal, because here is the volume is whole number, this one whole number, and then it's 50 degrees Celsius, 175 degrees, and it's no decimal there. So our answer, and that's what I don't like. I like to see decimal because that will be easy to figure out the sig fix. So let's give me the answer, and then we'll see that the sig fix. So how much? How much is it, guys? Somebody has it? No? Nobody has it? Come on, guys. I understand it's Monday, but just add this one here up. Multiply it by this value, 1.175. Okay? Okay, guys? And then here, then your number with the sig fix will be whole number, by the way. So when you add them, it should be whole number. However, this one here will give you what? Will give you decimal. So we'll go for the decimal. So this one divided by 50 plus 273.15. How much is it? Somebody has it? 74? 74 what? Liter? There's no decimal there? That's decimal or no decimal? Decimal? Decimal what? Yeah, give me the decimal. 0.105125, and this is liter. Well, look here, although this one here will give us whole number and this one will give us whole number, but here came out to be 0.175, which is the whole number will be less than the decimal. When we have sig fix, then we have to go by the decimal itself. So the answer will be 3 sig fix, because those are whole number, correct? So whole numbers usually, when it comes to decimal, they will be ignored, correct? They will be ignored. So ignore those whole numbers. This is whole number, correct? Ignore them. So here is 0.175. So we have 74.1 liters. So 3 sig fix. The answer is 3 sig fix. And I'm not sure if they have the answers here or not. Oops, sorry. Sorry, guys. Sorry. Sorry, I have to ask. Everybody has it? Everybody has it? No, yes, no? Always. So can I take it out? Okay, let's take the third one. I'm not sure if they have the answer here. So number, what we say, it was number 3, correct? So I don't know if they have. No, they have. They did not give you the answer of that. But anyway, but no problem. So this will be 3 sig fix. So let's take this one down. Let's take the next one. Come on, guys. Come on. Let's take the next one. After Charles' law, we have our friend Avogadro's law, correct? Avogadro's is our friend here. Yeah, because he has a lot of contribution, not only in this area, but he has even in the indirect molar mass of a gas. So indirect, uh, the whole mole calculations based on his contributions. So he did a lot of stuff for the gas. So that's Avogadro's law, which is number of moles, correct? So, and what we said about this law here, if you remember. So if we remember, that's what we said about this. The volume of a gas is direct proportional to number of moles, correct? And we said V1 over N1 number of mole, initial of volume over initial of moles, equal the final of volume through over the final of moles, correct, guys? That's Avogadro's law or gas law. Okay, so and here's give you the standard pressure and temperature. Atmosphere is used, but the 0 centigrade Celsius is not used. It's used what somebody 273.15 Kelvin. We don't use centigrade Celsius, but we can. That's we know it's 0 degrees, 32 Fahrenheit, or 273.15 Kelvin. We use the Kelvin ones. And 1 mole of a gas will give us what? 22.4 liter. Okay, so and there are standard, there are ambient temperatures. No, we'll not use this one here, 24. We'll use 22.4, correct? Not the 20 and the 24, but 22. So, okay, guys, let's take one of those here. Which one you like? Let me take this one out now. Just which one you like? Was that? I need things that we can use to utilize what? To utilize the conversion, correct? So one we have milliliter to 85 kilopascal. Well, the problem is we need the number of moles, correct? Sample has a volume of this at 45 degrees and 85 kilopascal. Determine the volume. Well, we can do that, but what this problem is this Charles or what the problem is? First one, tell me from looking what is given and what is asked, can we determine which law we can apply? Yes or no? Standard temperature and pressure is what? Standard we said here. We use this one here. But the temperature is 273.15 Kelvin, capital K. Now, a sample of carbon dioxide has a volume of this. So we have volume, that's initial, correct, which is this one here. This is centigrade Celsius, this is T initial. And that's the pressure here. Again, that's all of it is initial. All those are initial, correct? Determine the volume at STP and SATP. We'll not put the ambient, we'll put the just STP, which is 22.4 liters. So, well, what type of this we can see? We have the volume, the temperature, and the pressure, initial, and the final at STP, which is this one here. We have the volume, V final, is 22.4, correct, liter. And then say determine the value. No, it's not given to us. It's a standard one. So that's we don't know. Okay, guys. So let's see. So then we have the pressure is 1 atm, and the temperature, that's final. And the final here is 273.15. That's STP. So what you can tell about this, what type of the formula we have to use. We need this one here. But this is given us, this is given, and this is given there. So and the pressure is given to us too. So what type of this? So this is not Charles. This is not Charles' law. What type of law is this? Somebody remembers? Come on, I know it's Monday, it's hard. But did you hear about combined gas law? You have all those three together, keeping the number of mole constant. So PV1, 1 means initial, T1 equal to PV2, T2. Now we are looking at this one here, V2. That's a combined gas law. And this is very important. Before you attempt any solution for any problems of this chapter, ask yourself what type of law. We have 8 laws. The last one here is not coming there, but 7 laws. What should I use? Which one I have to use? Well, this one, see what is given to you. Put all this given to you. The volume, V1, this the P1, the pressure is given to you, is in kilopascal, correct? 85.0. That's given to you. Volume is given to you. That's the volume, has to be correct. Temperature is given to you, is 45. That's given to you. So the standard one, the pressure is 1 atm, given to you, the final. The volume we don't know. The T2 is 273, is given to you. So this is a combined gas law. Now, what is the problem with this type of setup? What we have to do? Well, we have a lot to do here. We have 3 units we have to take care of. 3 units, correct? So can I take this one out? Can I take this one out? It's a combined gas law, and we have an issue with 3 type of units. So the units here is 55. I have to divide it by what? 1,000 liter to get it into liter. 1,000 milliliter per liter. So this one will be 0.0550 liter. This one here. Now the second one, I have to add this one here. 45 plus 273 point. Oops, sorry. Yes. 273.15. That's Kelvin, correct? And you can add those, will be 1.5, 3 is 8, 1, 3 Kelvin. Correct me if I'm wrong here. So 3, 8, and then 11, and then 2, 3. 318.15 Kelvin. And then we have a problem here, 85 kilopascal. I need to put what? ATM. Well, it turns out to be 1 ATM equal to 101.3 kilopascal. Pascal, capital P, is to honor the scientist. Okay, so I have to transfer this one here. So I say 85.0 kilopascal. I have 1 ATM at the top, or three digits, whatever. One ATM, 3 suffix, and here 103.3 kilopascal. So you look at Pascal. So that's 85 divided by 101.3. to get this one an ATM. So that's very important to set up all those units here and get them straightened up. So that's the problem here is combined low. So you just put all this here, PV1, T1 equal PV2 over T2. So then you can solve for the volume here. All those are given to you just with the correct units now after conversion. So then set up those and solve for V2. So, but I need to get the Charles law. Where of this here? Can I take this one out? Everybody has it? Everybody has it? Okay. Where from this setup here, this worksheet, is I have to look into Charles law. Not Charles law, the Avogadro's law. Which one is Avogadro's law? Which one, guys? Which one? Yeah, that's the law here. But I need to see which problem I can use for the problem here. This is the Avogadro's law here. That's correct. That's Avogadro's law. Which one? Which one the problem we can use as? Somebody will tell me. Number 5. A sample of cooking gas taken from a cylinder was collected and its density is measured at 27 at 100 kilopascal. The density is at those conditions 1.7 gram per liter. What is the molar mass? No, that's not. That's different. That's a different way. So we can use the gas law to determine. How about the number 7? Can we do number 7? Or if it does not make it, number 7 is number of moles. How to get number of moles? If you have number of grams, how you get number of grams for oxygen? Somebody will tell me number of moles for oxygen. Come on, guys, don't let me down. Moles is what? 4.80 grams of oxygen, correct? Over 1. Then you have to divide this by the molar mass of oxygen, which is 16 plus 16, that's 2 oxygen, correct? 32.0 gram of oxygen per mole of oxygen. Grams with the grams cancels out. So 4.80 divided by 32 will give you number of moles, correct? So let me find another one for you here. Let me take this one here out. Can I take, none of them is really, it has Avogadro. So, but anyway, so you get the idea. Number of moles, let me see here if we can find another one. It has direct Avogadro's value. Here we can see that's the worksheets. The first one is Boyle's law. Can you see it? That makes my life easier. So correct, the answers are there. Not really difficult. The only thing is you have to watch. Correct. What is this person is when solving this problem? What did he really or she? I mean, the author, the professor here. He does not acknowledge that you cannot use millimeter mercury, but since he has them on both sides, he reduces the whole thing here. That's not correct. Don't attempt to do that. You have to transfer this one here by dividing by 760.0 because 1 atmosphere is 760, and this one here divided by 760.0 millimeter mercury per 1 ATM. Are you following me? That's the only thing is wrong. That's Boyle's. P1 equal P2 V2. Then solve for V2. Okay, guys? So that's Boyle's law. Any question about Boyle's law? That's a good one. It has everything there. So then we have to go and look at, I hope it has everything there. That's Charles' law again. See Charles' law again. Let's see what yeah. So some textbook will add just 270. Here it is. Some textbook, all this in iCollege, all this will do just 273 without 1.5. They ignore the 0.5. So when you add this one here together, 0, 3, 9, 2. Pull yourself down here. Pull yourself down. Pull yourself down. It's Monday, I understand. So now, without adding 0.15, that will give a little bit of when you come rounding off. I would rather not use this. I would rather use what? Rather the whole thing. See here, you put 293. Well, that's limits the sig figs. So I will take this one here out, temperature. I will add how much? 273.15. So I will add the 20 here plus 273.15. So this will be at 15392 Kelvin. So here it's supposed to be 15, but it's okay. So Charles V1, okay, that's V1. Temperature is T1. This is T1 here, but we transfer it into the correct one. The gas is compressed, means the pressure will be less. So to 4 liter, from 6 liter to 4 liters. So it's really losing with the compression 2 liters. The volume will be less by 2 liters. So then you'll set up here the V2 here. You calculate the temperature, what the temperature will be. Well, we know that the higher the temperature, the higher the volume. The lower the temperature, you lower the temperature, the volume by 2 units from 6 to 4. So the temperature will decrease. And that's really what's happening. See here? That's what's happening here. You started with this, 20. Now it is what? Can he use he or she can use centigrade Celsius? No. Centigrade Celsius answer is not correct. Are you following me here? Temperature are always given in what? In Kelvin. And the volume in liters. Not milliliters, not centiliters, whatever, in liters. And temperature in Kelvin. Correct, guys? And moles in moles. Okay, so let's take this one out. Can I take it out? Okay, so let's take now one at a time. So you have okay, Gay-Lussac's law. The gases we can take Gay-Lussac is between the relationship between pressure and temperature. Between pressure and temperature. So it means the higher the pressure, the higher the temperature. The lower the pressure, the lower the temperature, and vice versa. Correct? That's what this says. This is T1. So it's give you the gas. That's in English. That's the pressure in English. Correct? And that's again did not really have the time to convert it, because he or she authors came up with the same idea with the whole thing, both sides. But this is again is not correct. This is not correct. It has to be when you calculate, you have to be consistent with what you have studied. Correct? You have studied, and one of the units in 1 atmosphere is 14.7 pound per square inches square. So then the square inches is 14.7. That's the relationship between them. Correct, guys? So pound per square inches, that's the pressure in English system. But we are using what? We are using metric system, and we have to use the pressure in what? In ATM, So with this one here in mind, this one has to be divided by 14.7 pound per inches square in each one ATM. So it will come ATM there, and this one here divided by 14.7 pound per inches square per one ATM. So it come. Then you can cancel it, but the author took it easy because you have both sides pound per square, so they cancel themselves out. But I'm not recommending this because sometimes they are not equal both sides. One will give you English, one will give you metric. One will give you English, one will give you Kelvin. So you have to watch for this. Okay, guys. So let me take this one out. And this is Gay-Lussac's law. Spelling is Gay-Lussac's, but not Gay-Lussac's. It's Gay-Lussac's, it's A. Gay-Lussac's law. So 30 pound per square inches, that's the pressure over the temperature 300. Where's the 300? The 300 is, see, that's the problem here. It's adding 273 plus this one here. That will defeat the purpose of sig fix. I have to add 1.5 and have always sig fix there. But anyway, so you add them up, you get the 300 Kelvin, and you can solve for the temperature. And the answer is 630. We don't need the answer. What is said? What the temperature goes in order to, yeah. So we'll not give it in centigrade Celsius. We give it in Kelvin. So, but he gave you the answer in what? In centigrade Celsius. Okay, guys. So this is Gay-Lussac's. Let's take this one out. Okay, so let's do Avogadro's. That's the Avogadro here at the STB. Okay, so let's look at the Avogadro's. 50 grams of nitrogen has a volume of dash liters, correct? At STB, and the answer is 40 liters. How it's coming to 40 liters? Let's look. 50 grams of nitrogen. What's the molar mass of nitrogen? Atomic mass of nitrogen, one nitrogen atom, is what? Look at it, is 14, correct? 14. 14 plus 14 is 28. So, but in the, so this one here is 28. That's the molar mass of two nitrogens, N2. Not one. One is 14. 14 point something, but this is 28. So then you have this one here cancel the gram of nitrogen with the gram of nitrogen there cancels. I like to have all the units there. Gram what? Gram nitrogen. That's what it's easy to follow. Then I have 1 mole of nitrogen, liter of nitrogen. It has to be there nitrogen because you can follow what's the whole thing. That's Avogadro's law. 1 mole of any gas will give you 22.4 liter. Okay, and the answer is 40. Now, if you look at the whole thing, the answer came out to be correct. Why? Because it started with one sig fix, correct? One sig fix, whole number. So end up what? One sig fix, whole number. That's Avogadro's number. And you can do all this stuff, correct? Okay, so, and here the number 2, the same like number 1. Number 3, what's the density of carbon dioxide at STP? Well, you have the molar mass of carbon dioxide. That's the molar mass. Molar mass in gram per mole. And then you have 1 mole here. That's Avogadro's divided by 22.4 liter. So mole cancels out. You have liter. This is 1.96 gram per liter. For gases, we use the liter here. So last thing here is the combined law, combined gas law. This is the combined gas law, guys. We talked about it, and we solved one of the problem, but we did not finish the solution. But this is the combined gas law, correct? And if you look at this, you look here, what will happen? Let's put the here it is. The balloon has a volume of this gas. This is V1. When the temperature is, this is T1. This one here, this one is liter, okay. But this one here, centigrade Celsius, we convert it into Kelvin. You cannot use it as is. This is millimeter mercury. This is P1. Has to convert it into what? Into ATM. Correct? What will be the volume? This is V2. We don't know. Temperature here is T2 and has to be converted into Kelvin. And this here, millimeter mercury, converted into P2 here, into ATM. Okay, guys, that's the whole setup of the combined law. So let's take this one here out. Can I have it? Let's go and look at this, what the author did. Okay. So again, it's the same issue I have here with this. This issue here did not convert this one here. This one has to be divided by 760 millimeter mercury to 1 ATM. This one here divided by 760.0 millimeter mercury per 1 ATM. We are not it's not good to have the habit not to convert those. You have to convert those pressures, the volume into ATM, the volume into liters, the temperature into Kelvin. Correct? And this is this is 106, this is V1, this is P1, this is T1. Well, T1 is somebody will tell me what's wrong with this. Somebody will be wrong with this gas balloon when the temperature is 45 degrees and the pressure is this. What will be its volume? Be at 22 degrees at 78 millimeter mercury. What will be at 20? 20 is this, which has to be 293.15 Kelvin. Correct? And start 45. 45 is 3,151 Kelvin. That's not correct. So 45.0 plus 273 will be 0713. So that's not 3,000. That's 317. Correct, guys? So I think that's one more minute, guys. Give you a long time, a lot of minutes. So let's look at this. We're almost there. So I think that's it. That's all the laws. So you have the quiz and the exam are posted, and please study them very well and do the online assignment. It's very important to do the online assignment. Thank you very much. Thank you, guys.